can really start building from the bottom up, from small little pieces, and somehow form your structure, which is exactly what we've done with this, then that seems to be the smarter way to go with, and so that has to be, as far as I can see as a chemist, that makes sense. I mean, that's what chemistry is all about, right? Hi, my name is John Stride. I'm an academic here in the School of Chemistry at the University of New South Wales. And one of the research projects that we're working on at the moment is Metal Inorganic Frameworks. These are highly porous materials which have huge internal volumes. We're really interested in investigating these pores. As you rotate it around, you can see these different pores appearing and channels, and see if we can actually put things in there. These range from being kind of absorbing environmental pollutants through to possibly administering drugs through these things. So then I started thinking, how can we do this? Surely at UNSW we've got some capability to do a printed 3D model of this stuff. So we had a few inquiries, asked around a few people, and finally, thanks to a contact in the School of Chemistry, I was put onto Hamid at the MMFI. Working with Hamid just by email. We never actually met. This is how simple it was. He got the idea of what we wanted to do very quickly. He could look at the models that we generated and say, yes, that's a possibility. We can go with that. At the end of the day, it was because it was so straightforward. It was almost like, well, okay, we'll just give it a go. We'll just print it and see what it looks like. And I do have these kind of crazy ideas of having these kind of beautiful kind of big structures of these things, in highly chromed or whatever, as almost as ornamental pieces, or you could use these as exotic wine holders or something, wine racks or something, right? Kind of because in and of themselves they have some inherent beauty, and at the moment they're pretty fragile, small models, but that's where I'd like to see the manufacturing go. This concept of bottom-up manufacturing, kind of additive manufacturing, where you can kind of build things up from metal powders or from resins or plastic beads. The traditional way, of course, is to machine. So you get a big block and you machine it out. Well, that's terribly wasteful. It's time-consuming. It's energy-intensive. It makes far more sense if you can build from the bottom up. And now, if we can start doing that at the kind of manufacturing scale, it's fantastic. And yes, so it's a fundamental part of modern day inorganic chemistry, and we believe that we're right at the forefront of that in this highly competitive field internationally. We feel that we're we hope as a true Aussie we're kind of punching above our weight on this and competing against some of the big boys out there. So if you want to know more, you can look at my website at UNSW School of Chemistry. I'm happy to engage and discuss any aspects that you find interesting.